Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to be talking about relations. But before we get into relations and later on functions, we need to review interval notation. What is interval notation? Well, it's simply a fancy way of writing inequality solutions. So here's how it works. Whenever we're dealing with just a less than or a greater than symbol, we're going to go ahead and use parentheses. And when we're working with less than or equal to or greater than or equal to inequalities, we're going to use brackets. And whenever infinity, whether it be positive or negative infinity, is involved, we're going to always use parentheses. Now, when using interval notation, try to remember that the format is always going to describe the smaller value, comma, to the larger value. Okay, always smaller value to larger value. So let's go over a few examples. Let's write each solution using interval notation. Now, my humble suggestion is always to write a rudimentary graph so you can actually visualize what's happening with the numbers. So for our first example, we have x is less than 5. So I'm going to go ahead and just draw a little rudimentary graph here, put my 0 so I can have a place value. I'm going to rest my 5 there, and it's less than. So I'm going to use a parentheses, and I'm going to shade to the left. Now the good news, you may say, oh, we got to do so much work. It's actually a lot easier to do it this way because now we know that we're going to the left forever, which indicates my negative infinity. That is my smallest value. And we're running that graph all the way to the 5, which is the greatest value. And guess what? You're done. That's my interval notation. Let's take a look at x is greater than or equal to negative 2. Once again, make a rudimentary graph. Place your 0, place your negative 2. It's greater than or equal to, so we're going to use a bracket. And we're going to shade to the right. Once again, illustrating the interval notation. So my smallest value here is bracket negative 2, comma, I'm going to my largest value, which in this case we're going to the right forever, so that takes us to positive infinity. And we always end or start at infinity, whether it's positive or negative, with a parentheses. Last example, x is greater than 3. Go ahead and write our rudimentary graph, place your 0, place your 3. It's greater than 3, so I'm going to use a parentheses. I'm going to shade to the right. And then my smallest value is 3, comma. My largest value is, once again, positive infinity. Why? Because I'm going to the right forever. And that's how you do interval notation. It's pretty simple. Now, how do I go from interval notation to inequality form or set builder form? Well, it's the exact opposite. In this particular case, I have in parentheses 5 to positive infinity parentheses. Well, what's going to happen here is, again, I like to graph it out. It makes my life a lot easier. I've got a 0, I've got a 5. I'm going from 5 to infinity, so that means I'm going to the right. Oh, so that means that x is simply greater than 5. This is a good one. I have bracket negative 3 to 5. Well, I put my little 0 here in the middle, my negative 3 to the left of 0, my 5 to the right of 0. And I have a bracket on the 3, so that means it's going to be equal to 3. But then I'm going all the way to the 5 here with the parentheses. So when I shade everything in between here, my inequality is actually x in the middle is greater than or equal to negative 3 because we had a bracket, and at the same time it's less than 5 because we had a parentheses. And always try to remember to place x in the middle when you have multiple variables when you're dealing with inequalities. And then last but not least, I have negative infinity to 6. So I'm going to go ahead and place my 0, place my 6, and I know that I'm going to the left because my smallest value here is negative infinity. So I'm going to shade here from positive 6 all the way to the left. And then my inequality is simply x is less than 6. Why isn't it less than or equal to? Because remember, we had a parentheses. All right, so that's a nice little review of interval notation. Now let's get into the actual lesson. A relation is any set of ordered pairs, that being an input of x and an output of y, where y depends on x. That's what a relation is, okay? There's 4 ways to write a relation. We can look at it as ordered pairs, and as you can see, we have our x and y values here, 1, 8, 1, 4, 2, 9, 3, 2. It doesn't have to have any rhyme or reason or any pattern. It's just a set of ordered pairs. We can display a relation in the same way, but in a table of values. We're going to use the exact same ordered pairs, but this time in a table. So we've got our x values and our y values. We've got 1 and 8, 2, 9, 3, 2, and 1, 4. We can also use what's called a mapping diagram. If you can tell here, 1 relates to 8. 1 also relates to 4. Those are my blue arrows. 2 relates to 9. And then last but not least, 3 relates to 2. And then our final way of displaying a relation is via a graph. And as you can see here, I've already plotted all of the ordered pairs. So you have 3, 2, you have 1, 4, you have 1, 8, and you have 2, 9. So there you have it. You can write a relation which, once again, is a set of ordered pairs. There's no rhyme or reason to it. And you can use either ordered pairs, a table of values, a mapping diagram, or a graph. All right, let's go. Now, this is very important, so please make sure you understand, and if you need to pause the video, do so and repeat this for yourself. The domain of a relation is a set of all input or x values of the relation. And the range is the set of all outputs or y values of the relation. And you display domain and range using, of course, interval notation. So I'd like you to please state the domain and range for each of the following examples. Now, the easiest way to do this is for domain to go from left to right, because the x-axis is displaying the values from left to right. It's on the x values, it's on the x-axis, the horizontal line of a Cartesian plane. And the range displays the up and down values on the vertical axis called the y-axis. And you always go from least to greatest. So my domain here, as you can see, my furthest left value here is -3. My furthest right value here is 1, 2, 3, 4, 5. So my domain is going to be between -3 to 5. Notice I use brackets because the points here that I displayed are solid. If they were open circles, then I would have used parentheses. With regards to the range, let's look at my lowest value on the y-axis, which is going to be +2, and my highest value on the y-axis is going to be 1, 2, 3, 4, 5. So my range is going from bracket 2 to 5. All right, let's look at another example. My domain in this particular case, once again, ask the right questions. What is my furthest value to the left? In other words, what is my smallest x value? In this case, it's going to be here at 0. And what is my largest x value? Well, if you notice here, you've got arrows that are going to the right forever. So my domain in this particular case is going to go from bracket 0 all the way to +infinity. What's my range? Once again, let's look at the lowest value of y and then relate that to the largest value of y. So for my range, if you notice, this graph is going to go little by little always down to -infinity. And little by little, this graph is always going up also to +infinity. So my range would be from parentheses negative infinity, which is the lowest value of y, to positive infinity, which is the largest value of y. Let's look at this input-output table. Okay, let's look at the domain here. In this particular case, they give you a specific set of x values and a specific set of y values. So my domain for this particular example is going to be the ages. So we're going to make a little brace here, and it's going to be 36, 25, 42, and 41. No, you don't have to write it in numerical order, but you can if you'd like to. The range in this particular case is going to be, once again, we use braces because they're giving us specific values. You've got $8.08, you've got $10.57, and last but not least, you have $11.82. All right, how does it work for a table of values? Very similar to an input-output table. They've given you a specific set of x's and y's. So my domain for this particular case would simply be, we make our brace, 5, -1, -4, and 0. And for my range, I'm going to look at my specific y values, which happen to be 3, 4, 9, and -5. So for a graph, you have to really analyze where it's going, but for tables, they just kind of give it to you there. And then here for a set of ordered pairs. Once again, they've given you specific values. So my domain here would be braces, -3, 0, 2, 9, and 23. And for my range, I've once again got specific values of 14, 7, 0, -18, and -99. All right, last examples here. Find the domain of each relation. Well, let's look at our first graph that I have here. What is the furthest point to the left on the x-axis? In other words, what's the smallest x value? When we count that, we've got 1, 2, 3, 4, 5, 6, -7 here, which I'm going to label to make my life easier. And the largest x value is over here at -1. So my domain is bracket from -7, the smallest value, to comma -1, the largest value. For the range, once again, we look at the lowest y value, which I'm going to label here in purple, which is 1, to the highest y value, which is 1, 2, 3, 4, 5, 6, 7. So my range goes from 1 to 7. And of course, we're using brackets because we have complete full circles. That means the values are included. And last but not least, my domain for this little funky graph here, if you notice, I've got an arrow on the left side and an arrow on the right side. So that means that if I continue this arrow little by little by little, I'm going to the left forever, which indicates I'm going towards negative infinity, which is the smallest value of x. And if I look at the right arrow, I also notice that I'm going to go little by little by little to the right forever, which takes me to positive infinity. So the domain here would be from negative infinity to positive infinity. And of course, we're going to use parentheses because anytime we use infinity, whether it's positive or negative, we're using parentheses. And my range in this particular case, well, my lowest y value here, if you count, is 1, 2, 3, 4, which I'm going to label here in green, my -4 value. So that's the smallest value of y. And which is my largest value of y? Well, if you see the graph and you analyze it, you notice that the arrows, not only are they going left and right forever, but they are slowly but surely going up to positive infinity forever. So my range would be from -4 to positive infinity. And there you have it. Hope you learned a lot. Thanks for watching and come back anytime. Take care now. Bye-bye.